Okay, so first of all, you have a function here, right? You have a rational function, f of x is equal to x over x plus 5. All right, and now the first question it asks you is to state the domain, right? Ooh, give me 1 second, guys. Hang on, 1 sec. -5, yeah. So I will say the domain is -infinity to -5, -5 to infinity, okay? And, you know, stop me anytime here. Okay, the range. Okay, so for the range, it says here that you can graph this on your calculator and answer the questions, right? So why don't we go ahead and do that? Let's put it on the calculator, and we already know what this is going to look like, right? This is one of these reciprocal functions. So here, let's see, x over x plus 5. Okay, x over x plus 5. There, okay? So do you see, okay, so do you see that there is a horizontal asymptote situation happening here, right? So it's like leveling off, and then it's leveling off here. We need to figure out where that is, right? Where it is that it's leveling off, okay? So one way we can do that is you can do menu, analyze graph. I'm sorry, not analyze graph, window zoom, window settings, and we can make, you know, this go from like -1000 tab to 1000. Right? So take a look at that. Clearly there's one value there on the y-axis that this graph will not equal. So what I can do now is menu trace, graph trace, and just put in here 999. So right at the edge there, look at the y value. It's about a 1, right? So it looks like this can never equal y equals 1. So the range is everything except for y equals 1. Now, later on in this lesson, I'm sorry, in this chapter, we're going to learn how to do this analytically, right, by algebra. But right now, this is a good enough approximation. So -infinity to 1, 1 to infinity, okay? All right, so for the x-intercepts, I like to go back to the regular zoom. So you can do window zoom, and number 5 is standard zoom. That takes you right back, okay? All right, the x-intercepts, you can see there is 0, 0. I'm going to write it in function notation like this. If it hasn't specified, it's up to you how you write it. You can also do it as a coordinate point, 0, 0, okay? Y-intercept, same, okay? Okay, end behavior. End behavior. So here we're going to do limit of f of x as x approaches infinity equals, and then limit of f of x as x approaches -infinity equals. Okay, so as x approaches infinity, what y value, Andrew? 1, correct? And it's the same at -infinity, right? It levels off at y equals 1. Okay. Where is the function continuous? So what do you guys think? Is it continuous on this arm right here? Yes. And it's continuous on this arm. So it's continuous from -infinity to where does this stop here? At what x value? Ben? -5. And then -5 to infinity. Okay, increase, decrease. It's increasing, right? Remember, we read from left to right. It's increasing from -infinity to -5. But then after that, it's increasing again. Okay? And where is it decreasing? Never. Okay? Okay? Questions on that? All right. Next one. So here, the ones that follow, you should be able to do without a calculator. Okay? And for the rest of the chapter too, on a, on the test, for example, you should be able to do it without a calculator. All right. Apply the leading term test to find the end behavior. Okay, so remember how we did this one. The leading term is the term with the highest coefficient, x to the 5. And remember, you take the sign along with it, right? If it's positive or negative x to the 5. So now, for this one, this is positive, and it's an odd exponent, right? So again, we're going to look at the limit of f of x as x approaches to positive infinity and negative infinity. When you, by the way, and I'll talk about final exams in a little bit, but going based on what I saw in the finals, when you see this term end behavior, it's always two limits: positive infinity, negative infinity, never just one. Okay? All right, so here, this is positive and it's an odd power. That means it goes up on one side, down on the other side. And if it's positive, that means it goes up on the right side and it goes down on the left side. You guys remember that from before? Okay. All right, state the number of possible real zeros. Well, remember, if the degree is 5, that's the highest exponent, then it has that many possible real zeros. Turning points, n minus 1, 4. Okay. All right, let's solve these equations. So this first one here, we're going to square both sides. All right, so we're going to get 3x plus 10 plus 2 root 3x plus 10 plus 1 equal to x plus 11. All right, and let's simplify some of these. So we have 3x plus 11 plus 2 root 3x plus 10 equal to x plus 11. So what's this? 2 root 3x plus 10 is equal to negative 2x. That's it, right? The 11s go away. Yeah. So then, okay, see, now I can divide both sides by 2 because it makes sense to. So I have root 3x plus 10 equal to negative x. And now I can square both sides. So what do I get here? 3x plus 10 equals x squared. And I get a quadratic equation. So x squared minus 3x minus 10 equal to 0. X minus 5, x plus 2 equal to 0. X is 5 and negative 2. Okay, so let's check. Okay, so when x is 5, what do I get here? 5 times 3 is 15 plus 10, so root 25 plus 1. Is this equal to root 16? Is it? No, so that doesn't work. The other one, when x is negative 2, I get negative 6 plus 10, root 4 plus 1. So that's 3, equal to 11 minus 2, root 9. Hey, that works. So it's just x equals negative 2. Okay? Questions there? All right, so the next one is a little bit more straightforward. We're going to add 32 to both sides. So I get 27. Is that right? Yeah. Is equal to the 4th root of 6x plus 3 cubed. Okay. Okay, so there's like several ways to do this. So you have to raise both to the power of 4. So I get 27 to the power of 4 is 6x plus 3 cubed. Okay, but I'm not going to do 27 to the power of 4 because this is a non-calculator problem, right? So when I take a cube root though, now it's the cube root of 27 to the 4. Remember, you can also write it that way. Okay? Is equal to 6x plus 3. And this is something like the cube root of 27 to the power of 4. This is something that you have to know, like you have to be very quick on your feet with, especially for AP. Okay? So cube root of 27 is 3. Yeah, 3 to the 4. How much? You guys know. What's 3 to the 4? What's 3 squared?
9.
It's 9. And then square that, it's 81, right? So this is just 81 equals 6x plus 3. So 81 minus 3 is what, 78 these days? Yeah. So x is 78 over 6. Does that divide? 78 over 6. 13? No. Yeah? Yeah, 13. Still got it, even after the break. All right, so x is 13. Okay, so you should check, right? Because this is a 4th root. But I believe this is going to work out. Okay? All righty. Let's do some division. So find the value of k so that the remainder is 0, right? We're going to do synthetic division here because it's being divided by a x plus 4 linear binomial. Okay? So here, I'm going to have 1, 2, negative k, negative 60. And I always check the exponents. X to the 3, 2, 1, 0, all good. Negative 4 goes out here. 1 comes down, negative 4. Negative 2. 8. Ooh, 8 minus k. Multiply by negative 4, we get negative 32 plus 4k. So I get negative 92 plus 4k. Yeah? Okay, that's my remainder. I want it to be 0. So 4k is 92. So what's k? I'm going to let you guys do the math this time. Yep. Yell it out. Yell it out. How much?
23.
23. So k is 23. Okay. And again, it could be that you want the remainder to be 0 or, I don't know, negative 75, whatever. Yeah? Okay. All right. Let's do a little bit more. Okay. So this one says determine the least possible degree. Okay, the least possible degree. So is this an x to the power of 2? Is this a x to the power of 5, right? What's the least possible degree? Well, what do we have to look at? We have to look at a couple of things. Yeah, Neve, go.
You have to look at the turning points, right?
Yes, that's one thing we look at. So we look at the turning points, 1, 2, 3.
And then you could also look at the zeros.
You can look at the zeros. So 3 turning points. How many zeros? 1, 2, 3 zeros. So what do you all think? What do you think? How do we get turning points from a degree? From the degree. The degree, the turning points is the degree minus 1, right? So one other thing you want to look at, because look, if you just look at the zeros, you're like, oh, then it's a, like it's x cubed. But can it be a cubic function? Why not? And not about the turning points. What else tells you it can't be a cubic function? Ben?
The end behavior.
The end behavior. You see how both ends are facing in the same direction? That means this has an even power, right? So from that, okay, so if it has 3 turning points, 3 plus 1, 4 is the lowest possible degree, okay? Now it could be 6, right? But it can't be 5 or 7, okay? Okay, determine the end behavior. There's that term again. So I need 2 limits. The limit as x approaches negative infinity and the limit as x approaches positive infinity. And both of these are going up, so it's positive infinity for both. Okay, create a function with the same zeros and similar multiplicities. And it says it's sufficient to leave it in the form of linear factors. So the zeros here are x equals negative 5, 1, and 4. Okay, so my function, first of all, you have to say, because you have to create a function, you have to write f of x equals. Then, so it's going to be x plus 5, x minus 1, x minus 4, and then you have to fix the multiplicities. So at the negative 5, it's got to be an even multiplicity, right, Andrew?
Isn't there another? Oh, wait, yeah. Oh, no, we're looking at 0. Sorry. Never mind.
That's cool. So this has to be an even. The rest of them, because it crosses the y-axis, it has to be an odd multiplicity. So 2, 1, 1, that gives you the minimum of 4. So do you see another reason why it couldn't have been anything less than 4? Right? That's the lowest possible one it could be. Okay? So again, it could have been x plus 5 to the 4, and then x minus 1 cubed, and so on, right? So it could go up higher than that. Okay. Long division. Do you all remember long division? Yeah? All right, so let's do this long division. Molly, do you have a question? Sorry, I'm going to just call you out.
Oh, sorry, I was scratching my head.
Okay, no. So one thing Zoom did is it made teachers a little bit better at reading like expressions in the eyes, right? Zooms and masks too. So, so every time somebody's squinting or thinking, it shows up in the eyes and you're like, what's going on there? I'll wait for that question. Okay, so let's divide this. Can we do this? We can't do this by synthetic, right? Because it's quadratic. So here I have 3x cubed plus 0x squared. So some teachers out there say you don't have to put the 0x squared, but then, mind the additions and stuff. I like putting it there because it makes everything better aligned physically, right? Okay. So this first term divided by the first term gives us 3x. Multiply 3x cubed minus 9x squared plus 6x. So we're going to subtract One way to do that is by changing the signs and adding. So that goes away. 9x squared minus 2x plus 11. 9x squared divided by x squared is just 9. So plus 9. So we get 9x squared minus 27x plus 18. Subtracting. I get 25x minus 7. Okay. So my quotient, 3x plus 9, plus the remainder over this. Okay. One thing, okay? This is the remainder, right? And this is the divisor. When you're done, that remainder should always have at least 1 degree less than the divisor, right? So if the divisor is x squared, then the remainder should only be x to the 1 or below. Yeah? That's how we know we're like done with the process. Okay. Here we go. Synthetic division. Okay. So what are we going to do first here? Because there is a coefficient in front of the x there. Andrew or Ben, who's going to be faster here?
Divided by 4.
Divide by 4. So here we're going to get negative 3 over 4, but we also have to divide the top by 4, right? So 12 by 4, 3, negative 11 over 4, 9 over 4, 18 over 4 is 9 over 2. Okay, so 3, negative 9 over 4, and what's that? Negative 20 over 4, so negative 5. Oh, look at how nicely that works out. Positive 15 over 4. So when I add, what is that? 24 over 4, so 6. Multiplying negative 18 over 4, which is negative 9 over 2. Oh my goodness, it's a factor. Who would have known, right? Plot twist if I ever saw one. So what now? So this is going to be 3x squared minus 5x plus 6. Okay. And lastly, we're going to factor this. Okay. Given that x plus 1 is a factor, right? So we're going to start by synthetic division, negative 1. 1, 5, 8, 4. Are all the exponents there? 3, 2, 1, 0. Yes. 1 comes down, negative 1. 4, negative 4. 4, negative 4, 0. Fabulous. So I can rewrite f of x as x plus 1, x squared plus 4x plus 4. Yeah? Yes? No? Andrew says no.
Yeah, can you go over that really quickly?
The very last step? Sorry, yes, I did do that very quickly.
Yeah.
So this is a minus 1. So you always do x minus minus 1. So x plus 1. And then here, remember our initial degree was 3. And when you do synthetic division, the degree drops 1. So these on the bottom will be the coefficients of the depressed polynomial. So it'll be 1x squared, 1 less than 3, then x to the 1, then x to the 0. So that'll be x squared plus 4x plus 4. Okay? All right. And I can factor this further. So it'll be x plus 1, x plus 2 squared. Yeah? So f of x is x plus 1, x plus 2 squared. Isn't that lovely? Yeah? Yes, Ben.
Is it necessary to factor the x squared plus 4x plus 4? Like, do you have to do that in this?
Yes, because the directions say to factor completely.
Okay.
Okay? All right, so I'll stop the